It's not a problem. It's fine. Now, the causes of mass extinction. Volcanic activity. So one of them was due to glaciation, the ice age. Volcanic activities also cause mass extinction, and the three greatest mass extinction were believed to be caused by volcanic activity. What does this volcanic activity do? When a mountain erupts, an eruption, when a mountain erupts, it throws a lot of rocks which will shatter to form dust, forming a cloud of rocks and lava, ash, cinder thrown up into the air, making it difficult to breathe. Some regions will stay dark for months, making visibility and breathing very difficult, making it more or less impossible for the sun rays to reach the earth because it's covered by that cloud, that dark cloud. If the sun's rays don't reach the earth, who are the first to suffer? The plants suffer because they can no longer photosynthesize and they will start dying. The plants are the primary producers, or are the producers, sorry, which are fed on by the primary consumers which feed directly on plants, for example, the herbivores. So if the plants don't receive sunlight, they don't grow, they don't produce food, they die. When the plants die, who are the next in line to die? The primary consumers, the herbivores. And the secondary consumers, the tertiary consumers who die, all life forms on earth will die. This led to mass extinction. So volcanic activity, apart from the burning characteristic of the volcanoes, the clouds, the dark cloud that it forms, being toxic, it is toxic, it kills. The shade it throws on that environment, preventing sunlight to reach the earth and preventing photosynthesis and breaking down of the food chain. So in many ways, volcanic activities can lead to extinction, to death, but not just of one species, because all species were equally affected. All species at that point equally went extinct. This is mass extinction. Now, what are then the evidence that organisms in different places got extinct? The evidence is that when we say an organism is extinct, it means that at present times we can't find that organisms again, those organisms again. But what did they leave behind? They left behind traces, traces that we refer to as fossils. What are fossils? Fossils are preserved remains, for example, bones and teeth, or impressions, for example, footprints of organisms that lived in the past. How do we find these fossils? We find these fossils by through the work of some scientists that we call archaeologists. They will go at sites where there is possibility of finding fossils. They will excavate, they will dig the ground and reveal all these bones or impressions, imprints. And they will then take them to another group of scientists that we call paleontologists, who do the study of paleontology, which is the study of fossils. They will then study these fossils and try to explain to us what could have happened, at which time did these fossils form, and all of that. For these fossils to form, they will have to be found probably in ice. Ice would preserve them. Tar, the substance that they use in making your roads, if it flows over these organisms, it will preserve them. Most of their body parts will not get rot. If there are soft tissues like the muscles, skin gets rotten, at least the bones might not get rotten, will get preserved. And sometimes dried sap from trees, amber, could also then flow over these organisms and preserve them. Please remind me, I'll show you an organism that has been preserved in amber. I have them. Okay, and you will tell for yourself that for millions of years, these organisms will never get rotten. Okay, so they will be found as fossils. Humans are now doing it artificially and selling it because it looks beautiful as ornamental structures. Now, if we then find these fossils and these organisms are not present in today's life, it means that somehow these organisms existed in the past and went extinct. The fact that we find their fossils is evident enough that they existed. If they didn't exist, the question is, can we find their fossils? The answer is no. Now, if we are finding their fossils and they are not here in this present time, what happened to them? The thing that happened to them is that they went extinct. So on the left here, you have a picture of some fossils. The first one is the picture of the ammonites. The ammonites are called mollusks. Mollusks are organisms that don't have bones. For example, like the snails, they have no bones. Okay. The ammonites were called mollusks, which were floating or present in swarms, in groups, in the sea. They belong to the same group as octopus. If some of you have eaten octopus before, it's very sweet and juicy. It has no bones, slimy and excellent. Okay, I know some of you have eaten it. Now, somehow they went extinct. What does it mean? It means that we can't find any representative member of ammonites in today's life. Now, on the second picture below here shows trilobites. This is the fossils of trilobites. They are marine arthropods. Arthropods are a group of organisms which have an exoskeleton, like insects. They have their skeletons on the outside. If you take maybe a beetle is hard on the outside. That's an arthropod. Okay, they are related to the lobsters. So we have arthropods in the oceans. They are related to lobsters and crabs. But trilobites are also extinct. Now, the next one are the bivalves. The bivalves are called bivalves because they have two shells. We still find them today, but we were able to find old fossils of bivalves. It means that somehow they had existed, but they did not change much over millions of years. There are two shells. If you separate them, they look exactly like one another. They form what we call mirror images of each other, but they are somehow curved or hinged at one end. Okay. So scallops are examples of bivalves. We'll see where we found bivalves here in South Africa, and trilobites and ammonites. On the left here we have a picture of whales, a fossil of a whale. This whale here was found, this fossil was found in the Sahara Desert. Now the desert is a place where we can't find water, more or less, except you find an oasis, the little spots where you can possibly miraculously find water. Otherwise, the question is, what was a whale doing in the desert? It brings something to our mind. It means that that desert was once an ocean. But over time, throughout the history of Earth, for some reason that ocean dried out, such that we are even able to find skeletons of whales, fossils of whales in the desert. It's not that some people from Soshanguve carried a whale on their head and were walking, went up in Africa, right at the top of Africa, to go and drop the whale in the desert and say, take it. No, that desert itself was already an ocean in the past. It just dried out. Now, you will have to remember these places. Fossils of bivalves and ammonites were found in KwaZulu-Natal. Fossils of trilobites were found in the Karoo. I'm sure you saw the Karoo biome. While fossils of whales have been found in the Sahara Desert. Like I was saying, what does the presence of these fossils in these areas mean? It means that if we find marine fossils in the desert, it means that those areas at first were oceans. Okay, they were once covered by oceans. And today, the fossils, also the organisms, the extinct organisms are no longer alive today, And they may, if they are alive, they may just look very different. Okay, they look very different from present day organisms. Okay, those are the organisms that we talked about earlier, and they got extinct over a million years ago. Now, this brings us to the end of the history of life, the end of part 2. You can go through the different terminologies that you'll find there. Some terminologies for marine fossils, fossils that were found in the oceans, bivalves, marine mollusks, and all of that, trilobites. The bivalves are marine mollusks with 2 shells. Trilobites are marine arthropods that are distantly related to lobsters and crabs. Ammonites, extinct coiled mollusks that swam or floated in the sea. Paleontology, the study of fossils. Fossils, remains of ancient life forms that have been preserved in other substances. And you can go through all those terminologies. Okay, glaciation, everything is there. I'm going to send this file as a readable file so that you can read and also make notes out of them. Thank you for attending. Something for you to do.